Hello everyone, hope you guys are doing well. Today I want to explore further upon blockchain technology. In particular, I want to share what I learned about blockchain's consensus mechanism. With that stated, let's jump right into it. Blockchain consensus mechanism. So to do a recap of last time, blockchain technology is a chain of blocks that holds information, and this mechanism is the foundation of all cryptocurrencies. Blockchains are characterized by block, hash, nodes, and consensus. Last time we didn't really prioritize upon consensus, which is the building block of what blockchain technology is, and it holds potential to change the nature of trust. So that's why I'm dedicating this presentation to consensus mechanism. The participants inside the network run the blockchain technology by coming to a consensus on the state of the ledger. And a ledger is just another word for a count of transactions. And the main idea behind blockchain technology is to increase transparency and efficiency. The blockchain network requires voluntary democratic participation and values individual sovereignty and the control of wealth. And cryptocurrency, think of it as a digital currency that is created through algorithms. And cryptocurrency is considered money as it fits the three characteristics of money. We discussed this. The three characteristics, which is unit of measure, medium of exchange, and store of wealth. A great example of store of wealth would be Bitcoin, for example. And Ethereum and USDC stablecoins, that's all proved to pass these three criteria. And crypto's value is quite driven by the decentralized application it enables. Think about how blockchain creates an infinitely transparent sequence of events that has the potential to alter, again, the trust inside humans. How does blockchain alter the nature of trust? Well, I'm glad you asked. To understand how blockchain provides trust, we have to understand the double spending problem. Double spending is the act of trying to spend the same digital currency twice by creating duplicate transactions. The problem here is that counterfeit copies devalue the currency relative to other monetary units, diminish user trust, and decrease the circulation of the currency. So in a centralized system, double spending is solved where a trusted authority keeps a record of everyone's balances and authorizes the transaction before the money is transferred. Now, this is how decentralized systems such as blockchain have solved the double spending problem, which is through the consensus mechanism, preventing simultaneous transactions. So, let's give an example. There's three characters, me, Bob, and Charlie, okay? Let's say I have one Bitcoin and I send this Bitcoin to Bob, but at the same time, I try to send the Bitcoin to Charlie. So I sent one Bitcoin to two people. And both transactions goes to the unconfirmed transactions pool and it's put into a blockchain where they are checked for validity. So let's say that my transaction to Bob is pulled out from the unconfirmed pool and validated. Now this will go through because I have one Bitcoin and it goes to the blockchain, okay? As my transaction to Charlie is pulled out from the pool, to enter to the blockchain, it gets tested. And the result is invalid since I don't have another Bitcoin to spend. However, if both transactions occur simultaneously, we will have two chains where the first one to achieve the next block of confirmations win. So this race of validation, it constantly occurs and the blockchain that validates first becomes adopted. So the mechanism of timestamping transactions and broadcasting them to all the nodes in the network prevents a double spending. I hope that was a clear sense. So if we look at the picture over here, this is the initial state of the block, okay? And on the second picture, this is the blockchain continuing on adding more blocks. This one, the white one, is trying to cheat the system by creating a fork. And a fork is a change to a network's protocol that makes previously invalid blocks as transactions valid. So that's what it's attempting to do. It's attempting to make the white blocks valid. And it goes on a race, the yellow blocks and the white blocks. But since the white blocks, it proceeds and it's longer, it confirms much faster compared to the yellow blocks, it becomes adopted into the blockchain and published onto the blockchain network itself. I hope that makes sense. So now, the two major consensus mechanism models we're going to discuss is the proof of stake and proof of work. The consensus mechanism allows players to agree on the state of the blockchain, including individual transactions, data, and smart contracts. So proof of work is a system that requires members of the network to expend effort solving an arbitrary mathematical puzzle to prevent anybody from gaining the system. Bitcoin uses a system where miners are able to prove they put in the work and be assured that the transaction is valid. So the more you put in, the more chances of winning the reward. So if you have more computing power, the more likelihood of earning a block reward is. And anyone with a computing power can join the network. And if you want to attack the network to gain free coins or to change the network, you will need 51% of all the computing power. Whereas in proof of stake, a set of nodes decide to stake their own cryptocurrencies in the transaction validation. The larger the amount of the stake and the longer the duration of the stake, the better the chances of the staker to get transaction validation responsibility, which means they're also going to be receiving some type of reward. So players of proof of stake need to put in a stake, which is just money you put so that when you don't finish the race, it gets taken away. And if the staker doesn't validate the block due to technical difficulties such as not being connected to the internet or having a poor node setup, slashing occurs. And slashing is losing coins that you locked up initially. Thus, this kind of aims to guarantee that people validating nodes are reliable. And how do these stakers get picked, you might be thinking? It depends on the total coins, how long you've been staking, and also chance. All of these factors are used in picking out who becomes stakers. So now I want to wrap up by talking about the two costs of blockchain. The two main costs of blockchain is the cost of verification and networking costs. Verification cost refers to the ability to cheaply verify the state of the ledger, whereas networking cost refers to the ability to bootstrap and operate a marketplace without giving control to a centralized intermediary. According to Reuters, the average credit card processing fees ranges from 1.5% to 3.5% of each transactions, although the final percentage really depends on a host of factors. And these fees include payment processor fees, interchange fees, and assessment fees. And if blockchain is able to bring down the cost of verification, it can enable institutions to operate at a quicker and cheaper rate with a far lower error rate with a few resulting risks. And I truly believe blockchain has the potential to eliminate inefficiencies on the customer sides of charging high fees and capable of changing the nature of trust. Decentralized systems are more flexible and adaptive than centralized systems. Think about the nature of flowers. The reproduction of flowers is carried by pollinators such as birds, butterflies, and bees who carry pollen from one flower to another. So once this pollen on a bee reaches the new flower, the pollen travels down to the ovary where it fertilizes egg cells to create new seeds. If the reproduction of flowers was centralized, however, where humans are creating a single genetic flower, it is susceptible for failure, as if there's a defect on one flower, the whole system fails. So nature allows for robustness and diversity through decentralized system, and I believe that this technology has the same thing for finance and the health sector, supply chain, and so many different uses. With that stated, I'd like to end with a quote from Tyler Winklevoss. We have elected to put our money and faith in a mathematical framework that is free of politics and human error. I hope that this presentation reiterated the importance of blockchain technology, and my apologies if some of the presentation material did not make sense. I'm working on improving my speech as well as condensing it in a way that it's easily digestible. So please have some patience with me, but it's quite remarkable of how humans are able to create such progress and efficiencies to creating a better world. So hope you guys learned a thing or two. And with that stated, I hope you guys have a wonderful rest of your day, and I'll talk to you guys very soon. All right, peace.